Now, to get theta 1? Now, to get theta 1, the amazing tricks have been discovered. I have no idea how people came up with these tricks, but you will see that in the end result is pretty efficient. So the first trick, somebody noted that it is convenient to define two constants, K1 and K2. K1 equal to L1 plus L2 times C2, and K2 equal to L2 times S2. Okay? And therefore, the original equations for x and y, which are the green ones here, with a star, okay, so this is the same star equation, will be K1 C1 minus K2 S1 and K1 S1 plus K2 C1, which can be confirmed. I confirm it in black here. When I put back the definitions of K1 and K2 into this, I get these black equations, which are exactly the same as the green equations here. Okay, so we are working now with these equations with a star. Now, then somebody, perhaps even the same person, discovered that it is convenient to imagine a triangle with sides K1, K2, and the right angle here, angle gamma here, and this side of the triangle called R. Okay, so for this triangle, of course, R is the square root of K1 squared plus K2 squared. It's some old Greek theorem, right? And gamma is a tangent of gamma is K2 divided by K1. So the angle gamma is 8 and 2, K2, K1, right? So this is the triangle. And of course, the blue things for the triangle, obviously K1 is R cosine gamma and K2 is R sine gamma. It all seems completely disconnected. That's why I am so surprised that somebody has come up with this. So now look what happens. We go back to our star equation, okay? Say I already put R on the left side, but you can imagine that R is here multiplying this and R is here multiplying this. So you have K1 C1, so K1 is R cosine gamma times cosine theta 1, right? Minus K2, which is R sine gamma times sine theta 1. So R not here, already taken into the denominator here. And the same idea for Y. K1, which is R cosine gamma sine theta 1 plus R sine gamma cosine theta 1. Now, somebody who studied trigonometry may remember what these right-hand sides are. Okay? These right-hand sides are equations for the cosine and sine of sum of angles. Okay? So if you have a cosine and sine of the same angle, you can very quickly generate 8 and 2 out of them, right? So we have cosine and sine, and therefore gamma plus theta 1 will be 8 and 2 y over r and x over r, but of course, when generating inverse tangent, the factor makes no difference. It's just the ratio that makes difference. So r can be taken away, and we just get 8 and 2 with two arguments y and x. And therefore, theta 1 is being generated by a single line in the code, which is 8 and 2 yx minus gamma, and gamma, as we remember, is 8 and 2 k2 k1. Okay, and k2 k1 defined at the very beginning, known after theta 2 has been computed.